Okay, the third quantum number, okay, distinguishes what orbital you're in. Okay, and the orbital is which box you live in. So, the third quantum number, okay, represents which orbital you live in or which box you are in. Okay, and we know that, for example, an S only has one box, a P has 3 boxes, D's have 5 boxes, and F's have 7 boxes. And so we're going to describe which box we live in. Okay, and it's based on the quantum number before it. Okay, and so it's anywhere from plus the second quantum number to negative the second quantum number, and that's why there's an L up there in the PowerPoint. Now, if this is sounding a little strange, you're like, oh my goodness, it'll make sense once I do an example for you. Okay, so don't get stressed out that you'll get this. It comes with an example. I'm giving you a broad overview right now. Okay, fourth quantum number, next slide. Okay, it's called the spin. It's by far the easiest one to do, and it just tells you the spin. Okay, so we know that there is an up spin, which we will represent with a plus 1/2, and then we know that we represent a down spin, and that we will show with a negative 1/2. Okay, so the fourth quantum number is really easy. It's what direction the arrows are going. There's 2 possible spins. We're going to show each of the possible spins. An up spin and a down spin. Positive 1/2, negative 1/2. Okay. Now you've been given the broad overview, and so what we're going to do is we're going to do an actual element. Okay, we're going to do oxygen. Now what's cool is I want everybody to get out their problem set and open it up to page 59 for me, please. Page 59 in your problem set. And Tony, I'm actually done with the PowerPoint, so everything else is going to be on the board. Okay, so on page 59 in your problem set, you will notice that towards the bottom, I think is it number 10, is oxygen. Do you see oxygen on there? Okay, so we're going to do number 10 on page 59 together. It's oxygen. We're going to draw its orbital diagram first, and then we're going to figure out the quantum numbers based off of that. Okay, so here we go. So we're going to do oxygen. The first thing you have to do is you have to draw its orbital diagram or it won't make sense. I have to do that first whenever I do this because it gives me the picture I need to describe each of the electrons. Okay, so if you remember, we do the orbital diagram by drawing our boxes and our arrows. Okay, and so oxygen, okay, oxygen of course has a total of how many electrons? 8 electrons, okay, we get that from its atomic number. And so there is a picture of its orbital diagram. Now what we're going to do by doing quantum numbers is we are going to take what's a visual picture and put it into sets of 4 numbers. So every arrow up here is going to have 4 numbers that describe that arrow. It's set of quantum numbers. Okay, so the first quantum number, remember, is based off of the energy level you're in. And so that's that number right here, the number 1 or the 2. Okay, so Hillary, how many arrows do I have in energy level 1 right here? Okay, so I'm going to write 2 number 1s. Okay, 2 number 1s. Okay, now Tyler, in all of energy level 2, okay, the S and the P, how many arrows do I have total over here? 6, okay? So I'm going to write 6 number 2s. Okay?